Assalamualaikum. Today we are from Group 61 are pleased to present our project titled Single Phase Automatic Night Light from subject BNR 10303 Principle of Electrical to under guidance of Dr. FARIDAH HANIM bin Muhammad Noor. Before we start our presentation, our group consists of 3 members, Afizullah, myself, Abang Imi and Muhammad Akif. Introduction for our project. Lighting play a vital role in our daily life by ensuring visibility and safety. However, manual lighting system often cause system wastage and when lighting are unnecessarily left on. Our project focus on automatic night lamp system that use an LDR and relay to switch light on during the night and off during the day, depending on the ambient light level. The design was tested and analyzed using the 4-start circuit simulation to confirm its performance without using a real hardware. Next, our objective for this project are: first, to create an autonomous lighting control system using LDR. Second, to simulate relay switching in AC bulb using 4-start. Third, to study the behavior of voltage, current and power in AC circuit. And lastly, to improve lighting efficiency through automatic on and off simulation. The key component in our design is the light dependent resistance or shortly LDR. It reduces resistance in bright light and increases resistance in darkness. It's a pair with fixed resistor to the form of voltage divider, which it convert change light into a voltage signal. This signal is then monitored by a comparator and or transistor which activating the relay. The relay acts as switch, isolate the low voltage DC control from the high voltage AC load.
Assalamualaikum, my name is Muhammad Akif bin Muhammad Rafi'i and my matric number is CN240325. I will continue the presentation about system design and circuit diagram simulation. This automatic night lamp system consists of 2 main parts, the control circuit and the lamp load circuit. Both circuits are powered by a single phase 240 AC supply. The control circuit include a light dependent resistor LDR, a fixed resistor and OPM configured as a comparator and a relay. The LDR and fixed resistor form a voltage divider which convert change in light intensity into a voltage signal. This voltage is then fed into the input of the OM comparator. When ambient light fall below a certain level, the comparator output switch high, activating the relay. The relay then closes its normally open contact, allowing the AC current to power the lamp. In bright condition, the comparator output remain low, keeping the relay off and the lamp turned off. This switching system ensures the lamp only turn on when needed, saving energy. The resistive load like a 100 watt bulb is used to maintain a unity power factor. The entire system is simulated using the FASTAC online circuit simulator to observe how light level affect voltage, switching and lamp behavior. For the circuit diagram and simulation, based on the circuit that we made using the FASTAC software. Originally, the circuit used a fixed resistor and an LDR, but in the FASTAC, there is no LDR, so we use a resistor and change the resistance value to replace the LDR function. Then at first we use a transistor, but to simplify the process of making the circuit, so we use an OPM as a comparator and it decide whether to turn on or off the relay when the relay is turned on. The comparator output is high, the relay coil is energized, close the contact and turn on the light. When the output is low, the coil is de-energized, the contact open and the light is turned off. Firstly, the comparator output is low, negative, which means the voltage is below 0 volt for most the AC cycle. As a result, the relay is off, the switch is open, and the lamp is off. This is confirmed by the red and yellow wires, which show there is no current flowing to the lamp. This situation simulates daylight where the LDR receives light and its resistance drops, causing to decrease. The output is high, positive, indicating that is above 0 volt most of the time. The relay is energized, the switch closed, and the lamp turns on. All the wire turns green, showing positive voltage and current flow throughout the circuit. This condition represents night time where the LDR has high resistance due to darkness, increasing the voltage at the comparator input. At the bottom, the oscilloscope waveform show as a green sine wave and the 0 volt reference as a yellow flat line. When the green wave is mostly above the yellow line, the comparator output goes high and turns on the lamp. When it is below, the lamp turns off. The pulse in the output waveform means that the sensing voltage is dropping below 0 volt during part of the AC cycle. When this happens, the comparator detects that is lower than the reference voltage 0 volt. So the comparator output goes low, causing the relay to turn off for a short moment. This pulse indicates that the circuit is responding directly to the raw AC signal, which causes rapid on and off switching during each cycle.
Okay, so I will explain about the mathematical and analysis. So the given is supply voltage is 240 VSC and the lamp power is 100 watt and frequency equal to 50 Hz and the lamp behave as a purely resistive load. Load is energized only when relay is closed at the night time. So for the get RMS current through lamp, the formula is IRMS P equal to VRMS. So the answer is 0.417 ampere. So for the impedance is Z equal to R. Since the lamp is purely resistive, so the answer is 576 ohm. And the voltage for the voltage and current phasor, the voltage phasor is V equal to 240 volt and the current phasor I equal to 0.417. Phase relationship is voltage and current are in phase resistive load. And then for the power factor, PF equal to cos theta equal to 1.0. The power factor is unity because of no reactive power. And for the peak voltage and resistance, the peak voltage V peak equal to square root 2 multiply with VRMS. So the answer we get is 339.4 volt. So for the lamp resistance is R V2 V VRMS power of 2 over P, and the answer we get 576 ohm. And then for the complex power, so the formula is S equal to VRMS multiply with IRMS. So for the answer is 100.08 VA. So to get the real power is P equal to 100 watt for the mesh lamp rating. So for the reactive power, the formula is Q square root of S2 minus with P2. So we get the 4 VAR. Reactive power is negligible, theoretical 0 for resistive load. 4 VAR is likely rounding error.
Thank you to my fellow members for explaining the mathematical calculation analysis. Now I will talk about result of discussion. From the simulation, confirm that lamp turn on in the dark and off in the light exactly as intended. The system improve energy efficiency by ensuring the lamp only operate when needed. It also demonstrate the importance of electrical isolation using relay. Ascent safety and overall of the project is successful combined DC control with AC switching unit using basic and low component costs. Thank you to my fellow members for explaining the mathematical calculation analysis. Now I will talk about result of discussion. From the simulation, confirm that lamp turn on in the dark and off in the light exactly as intended. The system improve energy efficiency by ensuring the lamp only operate when needed. It also demonstrate the importance of electrical isolation using relay. Ascent safety and overall of the project is successful combined DC control with AC switching unit using basic and low component costs.